Hello, everyone. My name is João Viega. I'm Vice President, Sales, Marketing, and Service for CiDRA Minerals Processing, Inc., based out of Connecticut, where our technology is developed and manufactured. Here with my colleague, Joe Felix. He's General Director of Felix Project Management and Consulting, based out of Johannesburg, and serves the area of sub-Saharan Africa. We hope you will enjoy the presentation that we put together today. We appreciate the committee's invitation to be able to talk to you about what we think are some very compelling topics that are impacting mining today in a positive way. We'd first like to talk a little bit about technology adoption and innovation and some of the barriers which occurs both in our professional and personal lives, but also talk a little bit about what's driving the paradigm shift from older, more conventional technologies to newer, innovative technologies. Within this context, there is a tremendous need for industry to increase throughput, and we'll get into some of those factors and how one particular technology, real-time direct particle size measurement technology, providing particle size measurements in each individual cyclone, can create large benefit, particularly in automated control strategies. We'll finish up with a couple of case studies, and I'm sure you will definitely have access to the presentation. First, I'd like to put up on the screen the classic technology adoption life cycle. There are different stages, if you will, and different types of consumers, where in the beginning of a product launch, there's the innovators who are primarily interested in how the technology works. They are the gatekeepers before they pass it on to the early adopters to say, hey, this is a legitimate technology. The early adopter then takes risk, and they're generally risk adverse. They take the technology and say, okay, how do I make money out of it? After a while, the early majority starts to see the benefits and they start adopting it. In this technology S-curve, that's a very classic model. New technologies provide great benefit over conventional for a number of reasons. However, the main reason is because there's a lot of headroom in a new technology to grow its feature and invest. Think of the mobile phone going to the smartphone. Feature after feature, the user always gets the benefit and expanded features and value of these new improvements, whereas no amount of investment in a conventional technology could make it perform any better for the consumer. And you can see this here in this diminishing returns. Typically, over time, new investments are required. There's a paradigm shift, as I mentioned, occurring in the mining industry. A lot of us hear about the digital transformation of the mine, artificial intelligence, but I'd like to give tribute to International Women's Day from last month and highlight a woman who actually invented the flotation process. And that process has been used to this point. And as we all know, it's been incrementally approved, and it's still incrementally approved to this day, but there's just so much you can get out of it. So much you could do with changing the kinetic properties of the bubble and attachment of the mineral. What is driving the adoption acceleration in the industry? Well, certainly there are the macro driving forces, and by macro, I mean the resource sustainability, the resource that is used to convert the raw mineral into a usable product and value for the enterprise. And then there's the water or resources, energy, that is required and is limited to produce that product. And when you see at mines, especially aged mines, they have a falling ore grade, which is very much limited supplies, and they have to process more intensely. As everybody knows, there's a limited number of in-process and planned greenfield and expansion projects that kind of slowed down after the downturn in mining a few years ago. New mines take a very long time to execute, so there are very few of them. China's demand is up. As you know, China represents 50% of the consumption of copper. And again, mentioning there are water shortages, critical water shortages in some cases, and high energy and low energy supply in others. Coupled with all that is that copper is the metal of the future. So you have low supply, high demand, and now you have copper in EVs, you have copper in renewable energy products, copper wiring, so it goes on and on and on. So copper will be king, and the name of the game is how do I get that and increase my tonnage so I could make even more money at high prices. I think it's over $4 a pound now. Well, you could redesign your plant by putting maybe an extra ball mill in or sag mill, but that takes a long time and a large investment, and at times production's restricted. But you can, if you have the technology, to increase the capacity and tonnage quickly by relaxing the grinds tests, coarsening grind, and reducing the very valuable mineral losses going to the flotation circuits. So if we had a strategy, a control strategy that provided a real-time direct measurement of the particle size, that would make possible the reduction of the particle size band as narrow as possible to keep it within the optimal operating limits where we want to have efficient classification going to flotation. And also what we want to do is relax the grind task, grind coarser, without violating the downstream barriers into the flotation circuits, would reduce the efficiency of the flotation process, but also create maintenance to be performed down the road, thereby shutting down the flotation cell to remove coarse material and pebbles. So how do we do this? How can this be achieved? Are in this diminishing return zone of the technology S-curve. No matter what amount of investment is made in these technologies, not even incremental improvements can be made. They're mature and they're not adaptable to changing times. However, when one looks at the cyclone track particle size tracking technology, it's at the very beginning of the technology S-curve where investment generate increasing performance and value to its customer base. Cyclone Track PST is the only real-time direct measurement of particle size in each cluster. So the smart sensor is inserted in the cyclone overflow of each individual cyclone in the cluster or battery. It provides up to 5 real-time direct particle size measurements every 4 seconds and enables micro and macro control to increase tonnage and reduce variability. In addition, there are secondary benefits. One is controlling particle size variability over a range to prevent roping before it happens, not when it is occurring. Condition-based monitoring at the individual level occurs because we are virtually seeing inside of every cyclone overflow pipe the particle size variability, and they're able to take action to reduce that variability. Hence, the reduction of coarse particles and pebbles going into the flotation cell. Also, because we're grinding coarser and able to control that coarse grind to its upper limit before it hits the downstream process, we're lowering water and energy consumption. I won't go into too much how it works, but basically these smart sensor assemblies, the probe is inserted into the air core of a overflow cyclone pipe and all the cyclones in a particular battery. And the smart sensor serves as the waveguide, and when the particles directly impinge it, it creates a frequency. And that frequency is converted into a frequency spectrum where each individual particle is decomposed into its size. One of the benefits of this technology, amongst the others, are there's no calibration required. So when the probe wears, you could just take a new probe, plug it in, and if your cyclone configuration hasn't changed, there's no recalibration whatsoever. There's a lot on these slides, and I know I'm limited in time, but let's talk a little bit about microcontrol strategy. That's a simple strategy to implement into automatic control where you take the measurements of each individual cyclone, the real-time measurements, And from your strategy, simple logic of opening, closing cyclones, maybe resetting them, get your particle size range in the narrowest span possible. Also, of course, you would adjust other variables in your process. And this is real-time tracing of 5 particle sizes. I think the calculated P80 over time. And you can see right away how these cyclones are relatively clustered. Then all of a sudden, something happens here and this cyclone goes out of class. And then the client who had this and didn't have it tied into the control system had tried shutting cyclones off and seeing the effect, and then turning cyclones on, and there it gets it back into a relatively decent range. And that's a benefit even before you tie it into control. I would like to go back, and this is a very interesting comment. We've had this from the customer in South America and one in Bulgaria. Essentially says, having this information of individual cyclone performance is a wealth of new information that none of us have ever seen before regarding cyclone cluster operation. So I think that says a lot. What you want to do is to correct your process, you have to measure your process. And the best way to measure it is real time. The next is a macro strategy. Again, I'm going to use a cartoon here to show that once you have a consolidated battery P80 of all your batteries, now you could take and manage your plant and your processes to reduce the variability of each one of your batteries so that they're classifying all in a very narrow range to provide the highest benefit that you can derive from that, tying it into your control system. That typically is done right after it's tied into the individual cyclone management or micro strategy is tied into the control strategy. Again, here, large customer, mine from a large mine, a customer from a large mine, a real-time statement there. And of course, this prevents you from crossing your process barrier. This, we'll talk about net metal production value or NMP. This is the net metal production value before tying in PST in the system. And here's an improvement of tying it into the system. So you could bump right against that process barrier without violating it. There's a lot on our website about net metal production. But essentially and simply, it's head grade times throughput times recovery. Throughput and recovery are strongly related to correlated product size, and therefore NMP is a strong function of product size. How you maximize it, metal production, is typically grinding coarser. And you can see here, there's the old trade-off. Well, do I increase throughput and lose recovery, or do I try to optimize recovery and lose throughput? Well, if you focus on net metal production, that goes away. You're maximizing the net metal production with probably a slight loss of recovery and a slight loss in throughput. Value of the valuable metal is being optimized. Mineral Los Palabras published an NMP PST evolution paper in December of last year. As you know, they're a very large mine, and basically what they said is PST enabled an NMP strategy. And in fact, we hear from a lot of our customers that PST is enabling and leveraging their investment in artificial intelligence now that they have real-time measurements. Our lead customer originally was Rio Tinto Kennecott, large copper mine in Utah, as you know. These are the benefits they measured during us working together. That all, again, is in a paper on our website, but essentially a 10% increase in production. We typically see these numbers. I would say if you look through all our case studies, the increase in tonnage is between 8 and 10%. Here's a large Chilean copper mine who did extended testings after they tied in PST into the automatic control, and using the NMP model, they calculated a value of $60 million that was achieved during the trial with PST technology. I think it was a 4-month trial, 6-month trial, and that was only on one battery. And in conclusion, we hope today we have stimulated some thought regarding the need for reliable real-time measurement of particle size in particular to change the existing operating milling paradigm and help enable the digital transition of the mine to one of more automation. The use of the Cyclone PST technology integrated with the expert system enables the decrease in variability and ensuring a quality product to the flotation. And finally, the integration of PST measurements into an expert system enables an unmatched performance improvement and complete grinding process than conventional measurement systems. We thank you for your time and look forward to any of your questions. Thank you.